Okay, we're moving on in Unit 7 today, even though I'm gone. Definitely going to want to pay attention today. It's a very important topic that we're talking about with intercepts. If you look over at the board or if you look at your essentials map, the second essential question for this unit says, how do we use slope and intercepts to understand and graph linear relationships? Today we're really going to dive into intercepts, just as far as finding them and graphing lines using intercepts. And then we'll talk a little more tomorrow as far as understanding linear relationships and story problems. So we really just need to understand what intercepts are, what x and y intercepts are. So you definitely want to follow along, fill in your notes as I go through this, and make sure that you're paying attention when needed. If we need to pause the video, pause the video. I'm trying to slow down a little bit for you to help you out, but I definitely want to make sure that we can get this information in. The intercepts of a line are an important tool in graphing linear equations as well as understanding linear relationships. I think I've kind of sold you on that. This is what you need to know, the definitions. The first thing that we need to understand is what the x-intercept is. The x-intercept, by definition, is the x-coordinate, and I might underline this in my notes, the x-coordinate of a point where the graph of a linear equation crosses the x-axis. If I'm going to try to simplify that, wherever that line crosses the x-axis, whatever that x value is at that ordered pair, that's your x-intercept. It will help when we get to the next slide of notes and we look at this and see it visually, but it's the x-coordinate where it crosses the x-axis. That's the x-intercept. Then on the same note, we would say that the y-intercept then would be, if you think about it, the y-coordinate. It would be the y-coordinate of a point where the graph of a linear equation crosses the y-axis. And so you kind of see how they relate to each other. We're looking for where do our lines cross the y-axis and where do our lines cross the x-axis. Especially the y-intercept is very important to us. This is the one that matters even more to us going forward, and we'll talk about that when we get into slope-intercept form. But both are important this week as far as just finding them and graphing them and understanding how they relate to an equation. So the x-coordinate where it crosses the x-axis, the y-coordinate where it crosses the y-axis. Visually look at your graph on the next slide of notes. This helps you quite a bit. If you look at the y-intercept, it's marked where it crosses the y-axis. You look at the x-intercept where it crosses the x-axis. So you're starting to get an idea. We're talking about where does it cross the y-axis, where does it cross the x-axis. If you just look at this picture, it says this line crosses the x-axis at 2, 0, 2, 0. The x-coordinate at this point is 2, and we said the x-intercept is the x-coordinate where it crosses the x-axis. So the x-intercept of this line right here is 2. That's the x value where it crosses the x-axis. Hopefully we're starting to get an idea behind this now. It says this line crosses the y-axis at 0, 3. The y-coordinate at this point is 3. And again, the y-intercept is the y-coordinate where it crosses the y-axis. So you could fill in your notes that the y-intercept is 3. And so something that we've kind of already talked about a little bit that we really want to recognize when we look at this is our next question on your slide. It says, what do you notice about the ordered pairs? How could you find the intercepts without graphing? I want you to first look at the y-intercept. Let's talk about the y-intercept up here. If we look at the y-intercept, notice no matter what, wherever I fall on this y-axis, the one thing that I know about my ordered pair is that x is going to be 0. Because if I'm on the y-axis, I haven't gone to the left or right at all, and we know that x will be 0. Conversely, then, if we look at the the x-intercept, if we look at the x-intercept, no matter where we fall on this x-axis, doesn't matter what ordered pair we're at, we don't know what the x value will be, but we know that the y value will be 0 because we haven't gone up or down. And so that's huge and critical for helping us find intercepts. And that's where we go next in your notes. We're going to find intercepts. Very, very important. Got to have this for the rest of this week. To find the x-intercept of a line, substitute 0 for y in the line's equation and solve for x. And so obviously big critical idea here that we're going to substitute 0 for y and then we're going to solve for x. That's how we find the x-intercept. Substitute 0 for y and then solve for x. We'll do an example here in a moment, but that's the basic idea. Use that equation and do some substitution. Same idea here. You see to find the y-intercept, if you think about it, to find the y-intercept then we're going to substitute 0 in for x in the equation and then we're going to solve for y. And again, it's a very, very, very important topic here as far as what you're going to do to find each of these. And we'll do a couple examples today, and then you'll get some practice as well. Again, the idea behind it, at the x-intercept, we know y has to be 0, so we can substitute 0 in for y. At the y-intercept, we know x has to be 0, so we can substitute 0 in for x. Let's do an example in your notes. I would definitely want to be copying and following along as we go here. It says find the intercepts of the graph, 3x minus 2y equals 6. Well, we'll start with the x-intercept. We'll try to find that first. And so if you look at your notes up top, it says to find the x-intercept, we're going to substitute 0 in for y, and we're going to solve for x. So I'm going to write that exact same equation that I see, but wherever I see a y, I'm now going to substitute a 0, and then I'm going to solve that equation for x. So notice I start with the normal equation that we have, 3x minus 2. Instead of putting a y, I'll put a 0. and that all equals 6. Now we're just looking at a pretty basic equation that we're going to solve. 3x minus 2 times 0 equals 6. 2 times 0 is 0, so I have 3x minus 0 equals 6, and of course 3x take away nothing is still just going to be 3x. So 3x equals 6. To use inverse operations here, try to get x by itself, we divide by 3, and x equals 2. We found the x-intercept. The x-intercept, there's the bell, the x-intercept is x equals 2. We're going to work on the same idea then to find the y-intercept. So if we were going to find the y-intercept, think about how this changes now. Instead of putting a 0 in for y, we're going to put a 0 in for x. So I should see 3 times 0 minus 2y equals 6. Again, the nice thing about this, those zeros go away. You're left with just a negative 2y equals 6. And again, use inverse operations to get y by itself. Divide both sides by a negative 2, and we see that y equals negative 3. So we now have an x and y-intercept. The x-intercept is 2, and the y-intercept is negative 3. What helps us with this now is we have a new method for graphing. Instead of using a table and finding 3 ordered pairs, we're going to use these 2 ordered pairs to graph our line. So if you move along in your line, we're looking at on your notes. This is the same equation that we just talked about. It says use the intercepts you found, graph the equation. So we remember then that we said, well, the x-intercept is going to be 2, and the y-intercept is going to be negative 3. So we're going to use that to graph. Well, the x-intercept is 2. That means that's where it crosses the x-axis. It crosses the x-axis at 2. So I'll start at the origin. I'll go 2 over. That is where our line crosses the x-axis. Our y-intercept is negative 3, so we're going to find that on the y-axis. We're going to go down 3. There are the x and y-intercepts for our line. Now all we have to do, just like before, connect the dots and draw arrows on the line. And that's as good as it gets right there. That's graphing using intercepts. And so notice it's nice because you use 2 ordered pairs instead of 3. It's not so nice because it can be a little tough to see that line with just 2 ordered pairs. It's not quite as accurate maybe as using a table. We'll do one more example in your notes together today. We're going to find the x and y-intercepts of y equals 2x minus 8, and then we're going to graph the equation. So again, think back. Let's find that x-intercept first. Remember, we said to find the x-intercept, we're going to substitute 0 in for y. That's what it said on our notes. For the x-intercept, we're going to substitute a 0 in for y. And so I should see 0 equals 2x minus 8. This is a little trickier of an equation to solve, but we can definitely do it. So 0 equals 2x minus 8. Cover-up method says to cover up the 2x. So I'll add 8 to both sides. So 8 equals 2x. Divide by 2, divide by 2, and we have an x-intercept of 4. That's our basic idea as far as finding the x-intercept. You should be able to maybe now find the y-intercept on your own. But again, we're just looking at, if I want to find the y-intercept, I'm going to put a 0 in for x. This is nice because a lot of stuff will just go away for you here. 2 times 0 is 0. 0 minus 8 just gives you a negative 8, and you found the y-intercept. And as we go back to slope-intercept form down the road, you'll really start to see why that makes pretty good sense. So again, now we're going to graph it. We have 2 intercepts. We can graph this equation. We have the x-intercept at 4. And we have the y-intercept at negative 8. Go ahead and try to find that x-intercept first. It's on the x-axis. It's 4 over. I'd plot that point. And then the y-intercept is a negative 8, so I go down 8 on the y-axis. The x-intercept over here would be 4. The y-intercept would be a negative 8. And now the last thing that you need to do, try to connect the dots with a straight line. Put arrows on both ends. That's finding intercepts, and that's graphing using intercepts. That's the big thing that we needed to be able to do today. So just remind yourself a little bit as far as how we found the intercepts. Make sure that we understand what those intercepts are as far as where they're crossing the x or y axis and what we are looking for there. And then just make sure that we really understand what they are, how to find them, and how to graph them. If you understand this, you should be fine for your assignment for the rest of the day, and we will finish your notes together tomorrow.